Welcome to a new unit of study, and we're going to begin by talking about the index laws. Some of this might be revision from previous years, or you may have forgotten everything and this might be brand new to you. That's fine either way. So let's begin. So just to begin with some definitions here, if I've got a to the power of n, what do we call this a and this n? Well, we call the a the base. So let's write base there. Then we call this n by many different names. We can call it a power. We could call it an exponent. We could call it an index, from which we get the index laws from. So these are all the different names we give to this right here. It's a power, it's an exponent, it's an index. And what does it do? Well, what it does is it tells you how many times to multiply the base by itself. So if we think about just like a really simple example here for a second, if I gave you what's 3 to the power of 4, well, what that means is take 3 and times it by itself 4 times. That's what it means. So that can be an example there. Okay, now there's a whole bunch of laws associated with powers or indices. So let's go through each of them here, and I want you to write them down as we go through them. Okay, the first one is that if you're multiplying two things with the same base, you add the indices together. So in this case, what you'd end up with is a m plus n. So if we have this example here, x cubed times x to the 4, all you do is you go, well, what's x3 plus 4? It's going to be x to the power of 7. That's our answer. Now, if you're trying to think, how on earth does this work? Well, let's kind of think about this for a second. You've got x cubed, and actually, let me do it in different colors just to make our lives a bit more interesting, shall we? We've got x cubed, and then I'm going to times that. So I'm timesing x cubed by x to the 4. Now, let's think about what each of those things is telling me. X cubed is x times x times x. And then we're going to take that and times it by x to the 4. Well, what's x to the 4? It's x times x times x times x. How many x's do I have here? I have 1, 2, 3, 4, 5, 6, 7. Do you see how that's how we're getting x to the power of 7 there? Now, you'd be crazy to answer questions like this when you can use this neat little hack. And that's what we wanted you to get used to. Now, there's something you have to really take note of here, and that is that this law only applies when you have the same base. So what I would come and write here, we can even put a little asterisk, and I'll do it in red. Bases must be the same. And if you kind of think about why this is the case, let's say I gave you x to the 4 times y to the 2. Well, can you go 4 plus 2 in this case? No, you can't, because x to the 4 is telling you you've got x times x times x times x, and this is telling you you've got y times y. You can't add those together because they're two different things. So it does not apply there. Okay, we come to the next one now. Now, this is when we're dividing two things. And again, for this one, again, the bases have to be the same. So I'll write that initially. Bases must be the same. Okay, so let's go through this one. What the law tells us is that it's going to be m minus n. So when you're dividing things with the same base, you subtract the indices. So if we were to come over here, we would go, well, what is x 6 minus 2? And that's going to be what? What is 6 minus 2? It's going to be x to the power of 4. And if we think about how this works again, let's think about how this works. So we've got x to the 6, and then we're dividing that, that's a big division symbol right there, by x to the 2. Well, let's think about what each of these things is telling me. Let me just make that a bit smaller, shall we? And then I got rid of that 2 right there. Whoopsie daisy. Okay, what is this telling me? This is telling me that in the numerator, I have x times x times x times x times x times x. 1, 2, 3, 4, 5, 6. And then on the bottom, what do I have? I have x times x. I just have 2 of them. I have x times x. Well, what's going to happen here is that this will cancel with this will cancel with this, and how many am I left with now? I'm left with 1, 2, 3, 4. So I've just gone 6 minus 2. That's how I've got an x to the power of 4. So that's the thinking that's gone behind those laws there. We continue on. Isn't this exhilarating stuff right here? Hopefully you're finding it exhilarating as well. Okay, so here we go. Our next one here, we've got a to the m, and then the whole thing is being raised to another power. And what's going to happen here is that this outside power is going to distribute in. So that means what we're going to be left with here is a m times n. Okay, a m times n. What does this mean? Well, if we've got this, it simply means we go 3 times 4. And that's going to be equal to what? It's going to be x is 12. So that's all you're doing in those cases. Now, I'm not going to show you the thinking behind this one. I mean, if I could, but it would be here for quite some time. Because all it's showing you is that I've got x cubed, right? X cubed. And then I'm timesing it by itself like this, like this, like this. So I'm timesing it by itself 4 times. So it's x cubed times by itself 4 times. Well, now we could apply this thinking to it, couldn't we? And I could draw them out that many times. And what I'm going to end up with is 3 plus 3 plus 3 plus 3. And 3 plus 3 is 6 plus 3 is 9 plus 3 is 12. Or you could just go 3 times 4. And that's a lot quicker. That's the thinking behind it there. All right, we continue on. This one, again, has the same thinking behind it. What we're going to do, again, is distribute out this n. So it's going to go there and there. So that means what we're going to be left with here is a to the n, b to the n. So if we come over here now and we apply this same thinking, this 3 is going to apply to that 2 and that there. So that means what I'm going to be left with is 2 raised to the 3. Then, now this is where you got to be careful. This is x. And remember, these are timesing. So this is 2 times 3, which is 6. So that means my answer is, what is 2 to the 3? It is 8. And then x, 6. X to the power of 6. We continue on. Once again, we're distributing out. So I like to think about it as that to there. So that means we're left with a to the n over b to the n. So now when we come over here and we're thinking about it, we're just doing that same thing. This is distributing out there. That's distributing it out there. So that means I'm going to be left with 2 times 2, which is 4, and then 3 to the power of 2. So my answer will be x to the 4 on 9. And there we go. The next one is an interesting one, and that is when we have negative powers. When we have negative powers, what you do is you take the reciprocal and then swap the sign. So my negative sign becomes positive. So you take the reciprocal and swap the sign. That's what you do in these cases. So when I come to this, what I'm going to do is I'm going to say, well, I'm going to take this x and put it to the denominator, and then this negative 3 becomes a positive 3. And as we go through a whole bunch of examples, we'll be seeing this in action again and again, but that's the thinking behind it. You want to take the reciprocal and then change the signs, change the power's sign, change the power's sign. So negative becomes positive, positive becomes negative. And the same logic applies here. If I have a negative in the base, well, now I take the reciprocal, which means it comes up to the top. And I can even draw it like this. It comes up to the top now. And now this negative n becomes positive n. So this is just a to the n. So now when I come over here, I can do the same logic. I can bring this x up to the top. So now it's 3x to the 4. As you can see, the negative became a positive. So that's the same as 3x to the 4. Now, if I've got something like this, this is kind of combining this law with this law. So what we're going to do here is we're going to distribute out this negative n. So that means it's going to become a to the negative n over b to the negative n. And then I can take the reciprocal, and that will mean that the signs will swap. So what I'm going to end up with is b to the positive n over a to the positive n. So when you take the reciprocal, you change the sign of your power. So now as we come over here, we're going to do the same thing yet again. I'm going to say, well, this is the same thing as 3 negative 2 over 4 negative 2. So I'm distributing out that negative 2. And then I can say, well, if I swap it around, my powers will change. And now 4 squared is 16 and 3 squared is 9. So we'll be left with 16 on 9 there. Perfect. We now come to the lucky last one, which is saying, what is a to the power of 0? And if you ever raise anything to the power of 0, it's always just 1. So now when we come over here, well, again, we can kind of think about this as we have previously, as this 0 is distributing out. So that means we can say it's 3 raised to the 0 times x raised to the 0, which is the same thing as just 3 raised to the 0 is 1, x raised to the 0 is 1, so the whole thing will be 1. Now, it would have been a lot quicker if we just went, well, this whole thing, 3x, is being raised to 0. So that means my answer will just be 1. You don't have to go through this step here. So what I would recommend is you going straight from here to there. But the reason why I've put in this example is because now when we contrast it to this, now these look kind of similar, don't they? This and this look similar, but there's a big difference. And that difference is that this 0 is the power to all of 3x. It's the power to 3 and it's the power to x. When in this example, 0 is only the power to the x. So that means this is 3, and whoops, let me make sure the colors are correct here. That means this is 3 times x to the 0, which means it's 3 times 1, which is 3. So you have to be careful about where the power of 0 is. And that is it, everyone. Those are all the powers. What we're going to go through next is how we use them in the real world. I'll see you later.